Hello dear students, welcome to mathematics class. So up to the last class we have discussed some examples on the first case of finding the particular integral, means whenever the RHS is of the form e power ax. So here this is the first case of finding the particular integral, means whenever RHS is of the form e power ax, then 1 by f of d into e power ax equal to 1 by f of a into e power ax. Here the given condition is f of a should not be equal to 0. This one. This is the important condition, means here because f of a is the denominator of the RHS. If it is equal to 0, then that becomes indeterminate form, because 1 by 0 which is infinity or not defined. So therefore f of a should not be equal to 0. But it is not compulsory that for all the given differential equations of the form f of d into y is equal to e power ax, f of a must and should not non-zero, right? If it is equal to 0, then how to solve the differential equation? So that is the case of failure of the first case of the particular integral. So let us discuss if f of a equal to 0, then how to solve the or how to find the particular integral. So here this is the case. So now case of failure of 1 by f of d into e power ax. Now 1 by f of d into e power ax is equal to x into 1 divided by d by dd of f of d, means derivative of the function f of d with respect to d into e power ax if f of a is equal to 0. This is important. If the denominator is 0 or f of t equal to 0 for d is equal to a, then 1 by f of d into e power ax equal to x into 1 divided by f dash of d. D by dd is nothing but f dash of d into e power ax if f of a is equal to 0. So let us prove this one. So here if f of a is equal to 0, if f of a equal to 0 means what? A is a root of the function f of d, because f of d is equal to 0 at d is equal to a, means the value of d is satisfying the equation f of d. So means f of a is equal to 0. If f of a is equal to 0, then we can write that d minus a is a factor of f of d. D minus a is a factor of f of d. For example, here by writing the auxiliary equation. So here let us consider one example of finding that now here so here m cube minus 3m square plus 4 equal to 0. So this equation is satisfied for m is equal to minus 1. Then we can write that m equal to minus 1 is there, then that it can be written as m plus 1 is equal to 0 is a factor. So this is the factor of this equation. So like that, if f of a is equal to 0, then d minus a is a factor of the equation f of d. then f of d can be written as d minus a is a factor and remaining function is phi of d, because if here the order of the equation is 3, then if you take one factor outside, then the order of the equation will reduce by 1, means here it is m plus 1 into remaining function, that is of the form m square plus m plus constant, like that. So, here d minus a has came outside from the function f of d, then the remaining function is not equal to f of d. So, therefore, we are considering that as phi of d and consider this as equation number 1. Now, consider 1 by f of d into e power ax, which is equal to 1 divided by d minus a into phi of d into e power ax, which is equal to 1 divided by d minus a into 1 by phi of d into e power ax. Then this is equal to 1 divided by d minus a. The particular integral of 1 by f of d into e power x is equal to what? 1 by f of a into e power x. So, here it is 1 by phi of a into e power x. Just to substitute x equal to a. Then this is equal to 1 divided by phi of a into 1 by d minus a into e power ax. So, here we know that capital D. So, what is capital D? It is the operator d by dx, and if we write 1 by d, so here we know that d is equal to d by dx, then 1 by d means that is the inverse operator. So, what is the inverse of differentiation? That is nothing but integration. So, therefore, this 1 by d represents integration of the function. So, here we have 1 by d minus a, that is the inverse operator of the function d. So, therefore, it is equal to 1 divided by phi of a into e power ax into here e power ax into e power minus ax into dx. So, here we have integrating the function e power ax with respect to x and multiplying the term e power ax and dividing the term e power ax. So, here it is e power ax we have taken as it is, then or here for this term we have multiplied and divided the term e power ax, then that becomes e power x into e power minus ax into dx. Then this is equal to 1 divided by phi of a e power ax into integration of dx. So, it is equal to, so integration of dx is equal to what? X, then it is x into e power ax divided by phi of a, and consider this as second equation. On LHS it is 1 by f of d into e power ax. So, here we have considered f of a equal to 0, then d minus a is a factor and f of d can be written as d minus a into phi of d. Then consider 1 by f of d into e power x, just to substitute f of d, and here d minus a into 1 by phi of d into e power x, the particular integral of this one is 1 by phi of a. Then 1 by phi of a, then 1 by, here phi of a is constant because it is the value of the function at d is equal to a, and 1 by d minus a is the inverse operator. Then here multiplying and dividing by the term e power x, then that becomes e power x into integration of e power x into e power minus ax dx, and its integration is equal to x. So, x into e power x divided by phi of a, and the next step is, so it is equation 1. Now we are differentiating the first equation. So now differentiate equation 1 with respect to d, then that becomes f dash of d is equal to, so here f of d is equal to what? Well, first write f of d. So f of d is equal to d minus a into phi of d, and f dash of d is equal to, so differential of d minus a with respect to d is 1, so therefore phi of d plus d minus a as it is, differential of phi of d is phi dash of d, and put d is equal to a, then f dash of d becomes phi of a. So here f of d is d minus a into phi of d, and differentiating this one f dash of d. So first differentiate the first function and second function as it is, plus first function as it is, differential of the second one, and in this equation substitute d is equal to a, that becomes f dash of a is equal to phi of a. Then from equation 2, the second equation is 1 by f of d e power ax is equal to x into e power ax divided by phi of a. Then 1 divided by f of d e power ax equal to x into e power ax divided by phi of a is equal to what? F dash of a, right? Then this is equal to x into 1 divided by f dash of d into e power ax, because f dash of a can be written as f dash of d, because here a is equal to d. Hence it is equal to x into 1 divided by d by dd of f of d e power x, that is the derivative of the function f of d. So therefore 1 by f of d e power ax is equal to x into 1 divided by differentiation of f of d e power ax if f of a is equal to 0. Then this is the case of failure of the first case of particular integral. So suppose again denominator is 0, then again x into 1 divided by d by dd of f of d, then the process will continues until we get the non-zero remainder, non-zero denominator. So means here what is this one? 1 divided by f dash of d into e power ax, right? So if f dash of a is equal to 0, if f dash of a is equal to 0, then here x is already there. Then if denominator is 0, then it is x into 1 divided by differentiation of the denominator, that becomes f double dash of d into e power ax, means x square 1 divided by f double dash of d e power ax. And if f double dash of d is 0, then x cube into 1 divided by f triple dash of d e power x, and the process continues until we get the non-zero denominator in the function. Let us discuss the example. Solve d square minus 3d plus 2 into y is equal to e power x. So here the auxiliary equation is given by m square minus 3m plus 2 equal to 0. Then on factorizing this equation, we get the factors as m minus 2 into m minus 1 equal to 0. Then the roots of this equation are 2 and 1. these two are real and distinct roots. So therefore the complementary function is given by c1 e power 2x plus c2 e power x. So this is the complementary function for the given differential equation. And now let us find the particular integral. So here particular integral is equal to 1 by f of d, that is d square minus 3d plus 2 into e power x. So 1 by f of d into e power x equal to what? 1 by f of a into e power x. So here f of d is d square minus 3d plus 2, right. So here put d is equal to 1, because here the value of a is 1, means the coefficient of x. Then that becomes 1 minus 3 plus 2, then which is equal to 0, means f of a or f of 1 is 0, means the denominator becomes 0 at d is equal to 1. Then what to do? It is the case of failure. Then x into 1 divided by f dash of d into e power x. Then it is x into 1 divided by f dash of d, that is differential of the denominator with respect to d, that becomes 2d minus 3 e power x. Now, so here it is f of d, right. Then f dash of d is equal to what? 2d minus 3. So what is the value of f dash of 1? 2 minus 3, which is equal to minus 1, which is non-zero, right. So therefore it is x into 1 divided by 2 into 1 minus 3 e power x, which is equal to x divided by minus 1 e power x or minus x e power x. So that is the particular integral of the differential equation. Then we need to write the complete solution. So the complete solution is y is equal to c1 e power 2x plus c2 e power x minus x into e power x. So it is very important while finding the particular integral, first we need to verify that whether the denominator is 0 or non-zero. If it is equal to 0, then differentiate the denominator once, then proceed the same. If again denominator is 0, then repeat the procedure again, means again differentiating the denominator with respect to d, then substituting the value of a. The next example is d cube minus d square minus d plus 1 into y is equal to e power x. Here the auxiliary equation is m cube minus m square minus m plus 1 equal to 0. So here in the first two terms m square is common, then remaining m minus 1, then minus 1 is common, m minus 1. So therefore the factors are m minus 1 and m square minus 1. Then m minus 1 equal to 0, m square minus 1 equal to 0. So m equal to 1, m equal to plus or minus 1. So therefore the roots are m equal to 1, 1 minus 1. So here the roots are real, but 1 is repeated twice, right. 1 is repeated twice and minus 1 is, that is only once. Then whenever we have the repeated roots, then the complementary function is given by c1 plus c2x into e power x plus c3 into e power minus x. That is the complementary function for 1, 1 minus 1. So while finding the or while writing the complementary function, we should consider all the roots of the auxiliary equation. So if it is cubic equation, then consider the 3 roots, if it is biquadratic 4 roots, if it is quadratic 2 roots. Then and the particular integral is 1 divided by d cube minus d square minus d plus 1 e power x. So here f of d is d cube minus d square minus d plus 1, then f of 1 minus 1 minus 1 plus 1, which is equal to 0. So whenever we got the denominator is equal to 0 for the value of a, then we need to differentiate that once. Then it is x into 1 divided by, so differentiation of the denominator, that is 3d square minus 2d minus 1, then denominator here. So differentiation of 1 is 0 into e power x. Now f dash of d is 3d square minus 2d minus 1. Then f dash of 1 is equal to 3 minus 2 minus 1. Here substitute d equal to 1, which is equal to 0. Means again the denominator is 0. So therefore here again x into x, because x is already there, and 1 by f of d e power x, but f of d equal to 0, then what to do? X into 1 by f dash of d, again x into 1 divided by, so here differentiation is 6d minus 2 e power x. Now f double dash of d, right? F double dash of d is 6d minus 2. Then f double dash of 1, that is 6 minus 2, which is equal to 4, and it is not equal to 0. Then find or put the value of d. Then it is x square divided by 4 e power x is the particular integral. So here we have applied case of failure twice in this problem, because for the first one f of d becomes 0 at d equal to 1, and in the next step we got f dash of d, and again f dash of d is equal to 0 at d equal to 1. Hence again use the same condition, that is x into 1 by f dash of, means the derivative of the denominator, that is f double dash of d, and put the value of d and verify. So f double dash of 1 is equal to 4, which is non-zero. So therefore here x square divided by 4 into e power x. This is the particular integral. Then the complete solution. Then the complete solution is y is equal to c1 plus c2x e power x plus c3 e power minus x plus x square by 4 into e power x, which is the required complete solution.